In this video, we are going to get into lighting. We are going to learn the different types of lights, how the lighting system works in Unreal Engine 4, and hopefully putting some lights into our system so we can see things. First thing I'm going to want to do is I'm going to want to go ahead and shut off the light so we can go back to unlit mode, so we can actually place things properly. Now when I'm talking about lighting, there are a few different types of lights built into the system. If we go into modes, lights, you get access to the 4 primary lighting systems in Unreal Engine 4. We have our directional light, which we are actually technically already using. Let me actually go back to what I was saying. Turn on lit. Ooh, that was annoying. I hate eye adaptation. And let's go back to light source. This is actually a directional light. If we were to shut this off, you'll notice all of our lights disappear. Now you may be thinking to yourself, well, this looks really weird. We have a light. I can see a light in the background. Well, no, what you're seeing is actually a sky sphere, an atmospheric fog. If I was to shut those off, everything disappears. These are fake effects. These are pictures. These are pretty pictures in the background that are meant to give you looks. That's it. Our light source itself is the only thing actually casting light into our scene right now. Directional light is the sun. It's basically a universal light source somewhere far away that linearly lights your scene from a direction. If I was to go to my light source, which is right here, let's move this out of the way. We'll move it over here. The light source can be anywhere. It doesn't matter. All that matters is the direction. And if we look at it, we'll see this little arrow. That arrow is basically representing where the sun is casting to. And that's determined by our rotation. If I was to rotate it like this, you'll notice it's rotating along my z-axis. If I was to rotate it like this, you'll notice it's rotating on my y. And if I rotate it like this, it's going to rotate on the x. Let's reset this back. And basically, you want to adjust it to give you your little bit of cinematic feel. Let's go ahead and rotate this back. We can use this. And let's rotate it a little bit on here. Like this. And we'll give ourselves, we'll go something like that. That'll work for what I want. A little bit of light coming in. The next light is our point light. If we were to drag and drop one of these in, boop, we'll see a light. And it's exactly what it sounds like. It is a light that is a point that makes a radius that emits light. That's it. You have options like your intensity, which is how intense it is. Your attenuation radius, basically how much is going to be affected by our light. So for example, you can have a very bright light, but it's only going to affect a little tiny part of the world itself. That's this sphere, which is our attenuation radius. You, of course, can play with your colors and make things discotheque. It has plenty of options. Point lights are what we're going to use for the majority of what we're going to do inside of our scene right now. Now, if you notice there, one thing that happened is I went ahead and I did some really big adjustments like that. And then I reset them. And nothing happened. We have real time turned off, don't forget. With real time turned off, changes to our lights are not going to be affected in real time. So that's something to keep in mind. When you're working with lights, you may want to turn real time back on. And we're going to. Let's go ahead and get rid of that light. And we'll look at the last one, which we care about, which is spotlight. Our spotlight is basically a cone. It's got the same basic options, along with cone angles themselves. And it's a cone. It's a light that shoots in a direction that, of course, can be changed. And it places a spot light, circular usually, on an item. These are useful for mimicking spotlights, but they're also useful for adding like area lights. You could turn it down. You could turn up your angles pretty dramatically, for example. Something like that. And then you could have it maybe... let's drag this up here, something like this. Rotate a little bit, and you could use it to do something like that, and just give a little bit of extra light to your room itself. Nothing fancy, just a little bit of an extra a lighting effect, an ambient lighting effect. We're not going to use too many of those. Skylight is a light that goes into your scene, and it basically gives you a overall lighting to your scene. It's meant to mimic, something like kind of like your ambient overall light, whereas your directional light is from a direction and emits in one direction. Your skylight itself, like you can see here, kind of emits an overall light to everything. See how we have this general thing? Now we have these light in here because of the way our lighting is set up. That's actually what we need to cover next. If you'll notice, you have the word preview everywhere. There's two primary lighting systems inside of Unreal Engine 4. You have your static lighting system, which is basically a process that will run. It will calculate where all the light is in your scene and all your shadows and all your bounces, convert that into what it's supposed to look like, make that into a texture, and then basically apply that texture over everything. Static lighting will give you the highest quality, but it's going to take some time to build. However, it's the least flexible, and it is prone to issues. However, it's the best performance. Because you're not calculating light in real time, it took the hour or two before you built your game, before the player's playing to calculate the light, you're going to get the best performance. Dynamic lighting, which is the second lighting type, will eat your computer alive, especially a mobile device, if you have too many. Now, with that said, static lighting requires correct models, and you're going to see this issue here in a second. So for what we're doing, we're going to use dynamic lighting, and I'll explain why. So for static lighting, well, let's build out our static lighting, which is the process of converting all of our temporary lights into permanent textures, and this may take a few minutes. Now, we only have one light source in our scene, which is our directional light effect, basically our sun. And as it comes in, you can see we have previews and things like that. Build up here, if you just hit build, it's going to build everything. The lighting, the navigation, brush models, everything. You can go ahead and hit build. In our case, that's what I'm going to be doing because we don't have any of the extra stuff. But if you want to just build lighting, you can go down to build lighting only and build the lighting. Now there are other options, lighting quality and lighting info. By default, lighting quality will be preview, and it's going to take the shortest amount of time. You could, with a more intense scene, you could see something like 1 minute for a preview and an hour for production. So that's something to keep in mind. Building a final game with static lighting, you'll use production. For now, we're just going to use preview. So let's hit build and see what happens. Your first time you run the project, more than likely it's going to pop up with a Swarm request. Swarm is the third-party program, the external process that builds lighting. And you'll get a message log as well. Let me dock my message log. Let's bring this back. Dock my message log, and then go ahead and there we go. And we'll go back to here, and you'll notice now we have our lighting built. And we have a few fun issues. Inside of here, we're not really getting a bunch of lights. And that's because we don't really have too many places where a light can come in. We don't have any materials accepting our lights. And we don't really have too many incoming light sources. And that's because of the way that we've designed it. Our external light, if you think about it in real life, anything that relies on external lighting only, like your sun, is going to have huge open windows and huge open sources to get your lighting. And if it doesn't, like if it's a room or an office, you're going to have a primary light source that's going to be bright enough or in the correct spots to illuminate what you need to see. Then you also have secondary lighting, like your monitors on a computer or a watch or a phone. So there's a lot of lighting, and lighting is a very detailed process. We're just going to learn the basics, as this is an introduction, and get used to just getting lighting in our scene. Let's take one of our lights, a point light, and drop it into our scene. And we'll just drop it right here. And we will go ahead and we'll hit build. And what this will do is take our new lighting, build it out, make our light map, and then it's going to apply it to our scene. You'll notice a couple things. One thing, our floors are not being lit. Now, our floors are not being lit because we don't have a material assigned to them. And I've purposely done that on purpose. I've not assigned a material so you can actually see what's required for lighting. You'll also notice our walls are no longer smooth. We can actually see the separation between each of our items. Now, if I was to take this light and delete it, you'll notice we actually still have lighting in our scene. Remember how I mentioned static lighting, which is our default. It takes the light, figures out what it's supposed to light, makes a new texture, and that's called your light map, and then it applies it over everything. Because of that, our textures have light maps applied to them inside of here, and those lights are no longer needed. So not only are the lights no longer needed, they're not costing us anything, and as you can see here, we have a side effect of everything still being lit. Now the secondary side effect is if you were to move this light, even though it looks like things are still lit, you're going to need to rebuild your lighting again. If I hit play and I fall through the ground, that's another issue that I'm going to have to resolve here in a second. If I were to hit play, as you saw, the lighting itself said it needed to be rebuilt. That's because this light has now moved and all of your lighting needs to be recalculated. We'll go ahead and rebuild it and we'll recalculate it. And let me go ahead and fix my falling through the world issue. I completely forgot. And we'll take care of that in a second. Build it out. And there we go. You notice our lighting has now changed yet again. Let's fix our floor. Our floor itself is a static mesh, and like I said, it has no material assigned to it. If I was to go to my floor here and double click to open it up, you're going to find our static mesh viewer, and it's going to show all of our information. Any settings, default collision types, and shadow casting, and if it has a material, a bunch of fun stuff. Now, what we care about is our collision. Right now it's set to block everything, and we shouldn't be falling through it. The problem is collision requires a collision volume. By default, and this is something you'll run into, and it will always bite you in the ass the first time. Obviously, as you saw, it bit me in the ass the first time. When you convert something from a BSP, a geometry brush like I did, it does not build collision. So we just need to go into here. We'll go into collision, add a box simplified collision, and it's going to add a little bit of collision around it. We'll go ahead and save it out. We'll hit play again, and you'll notice my player can now stay on the ground. We'll notice also when I go over here, we're going to fall through the ground again. So, for example, what we care about is this. We have our light. Now, if we go over here, you'll notice we have the words preview, which, there we go, because I haven't rebuilt the lighting. It tells me an error. I need to rebuild lighting. But we've got the cool shadow effect. We can see a little bit of a glowy light on our character. And we have some extra neato features. But I mentioned during the process that we were using static lighting. So how do we have lighting built in, but still a light? Well, when I mentioned there were two types of light, dynamic and static, that is true. There is dynamic and static. But there is a hybrid called stationary. Stationary basically will build shadows and bounce lighting into geometry, which is why we have the light in the corner. But then it also treats basic lighting as dynamic. So we get dynamic shadows and we get the little glowy light effect on our character when it walks by. So it's a hybrid of both. You get a better performance than dynamic, but you don't get as good a performance as static, but you gain the benefit where you saw I get my little shadow. Let's switch over to the other light types and show you the differences. I'm going to take my light and I'm going to change it to static. I'm going to go ahead and build it out. And now we're going to see a pure static light. Once it finishes, of course, depending on the speed of your machine, lighting can take a while. This is also one advantage if you want to just block out a scene. When you're using dynamic, dynamic requires no building because it's all done in real time. We'll run this and we'll walk over to our corner. And you'll notice a difference. We no longer have a light affecting our player. There's no more dynamic spotlight and we have no shadow. And that's because we are now using pure static lighting. Static lighting builds everything into our scene, and this light basically shuts off when the game is running. It's not needed anymore. Let me switch this back to stationary. We're going to duplicate 4 lights. And again, this is what the awesome part about duplicating is. And we have 4 lights in our scene. And that light is definitely not in the corner. Okay, so there we go. That's 4 lights. And we'll notice we have an issue. Stationary lights seem like they're awesome, but they have a problem. You can only have 3 stationary lights within range of each other before they stop working, and then it switches the stationary light to fully dynamic, which is why you see 1, 2, 3, and then an X. If I was to run through this, you'll notice I have my shadows and everything, but I'm not really getting static lighting from all of these. I'm only getting static lighting from 3 of them. That is a downside of stationary. For the most part, you're going to want to use static and movable separately. Now, when we build this out, we've been seeing the really annoying issue of hard edges where meshes hit other meshes. This is an issue with static lighting. And due to the way your meshes are built, your UV is laid out, and just in general, the way static lighting is built. When you're building out static lighting, when it uses the light mask program, the swarm, it's going to assign every light, every texture, all of these different things to a different thread or process on your processor. Due to that, it can't really tell where the edges are for keeping the lighting. Basically, you assume this light broadcasts in this direction and it would be smooth. But the problem is this wall right here may be on a different processor than this one, not affected by the lighting the same, and it's going to have a hard edge. This is due to a few things. Our UV maps are not set up very well for these materials, for these meshes. If I pull up my mesh and pull up my UV map, and I go to my light map, you're going to see your edges, like here and here. This edge is not lined up with this edge. And these may not be on your exact grid, on your pixel grid, which means you have bleeding. In order to prevent these problems, you need to do a few things. You need to make sure your UV maps are as clean as possible along the pixel edges. No half edges not lined up properly. They need to be lined up properly. You need to make sure that you have meshes designed to light properly. Maybe, for example, if you have a statue, you would put your seams on the backside where the lighting wouldn't affect. In this case, because I'm meshing things together like this, Epic's suggestion is basically use props and doodads to hide your edges. You would do something like, for example, architecture, and we have a pillar, and you would find your edge like here. Boom, we put a pillar in there, and then we put a pillar in here. And you do things like that. You block out. Now let's find build. And you cover up your seams. The proper way, after all of this talking, is build your meshes properly. Build your wall as one contiguous unit so there is no chance of having an edge issue. If you have no edge, there's no issue. So as you can see here, by me putting in those 2 pillars, we've basically covered up our issue. We still have it over here, but we have an issue. If this was one continuous wall, we would have no issue. Now there is something nice built into our system. As you notice, when I deleted, we still have our shadow maps. There's something new that was added in 4.12, and you have the ability to merge actors together. If I was to take this wall, go to Window, Developer, Merge Actors, it's going to ask me what I want to do. It's going to select these ones. By default, I'm just going to go ahead and hit Merge. I'm going to choose my content meshes, and then we'll call this one, I like that, Merge Wall, 400 by 300. Actually, this would be what? Stack Mesh, 1200 by 300 wall. We'll go with that. We'll do save. And I've now created a new wall, 1200 by 300 wall. if I was to replace this like that, go ahead and build out, what we should see is a wall that's not going to have my lighting artifacts because I don't have any UV seams across here. Assuming my UV maps are done properly when it merges the actors. And as you can see, I've gone ahead and even though these walls have my edges, this wall is now one solid piece. If I was to pull it up and we check out our UVs, you'll notice we now have a solid UV across here. It may be 3 different things, but we have a solid UV channel right here. There's nothing interfering. There's no way to get a line introduced because it's going to light from here to here all the way across. So that's something you can do, but it's intended to illustrate that by correcting your meshes, by building them correctly in the first place, you won't have that issue. And that's an issue we're going to run into with static lighting. For the rest of this series, we are going to switch our lighting to dynamic because while dynamic may have a performance impact, we're not going to use enough lights to really have an issue, and we're not going to have that annoying problem. So I can go up here to light and search for all my lights. Let me go ahead and select all my lights and change them to movable. Once we do that, we'll immediately see a change in our scene. First thing we notice, we now have lights coming in from outside from our dynamic light source that look better. Second of all, let me hit build. Keep in mind, we still have our static lighting built and being used in our scene. Right now I need to rebuild. It's going to go through. It's going to find all my static lights, which I have none, and it's going to build out my light map, which is going to be empty. Now you'll notice I have smooth edges on all of my connections. Even though I have 3 here, I now have smooth edges. I have a nice light coming in. I have a nice light from bright outside. And we have a nice lit up illuminated room. And this is what we're going to use for our example from now on. Moving on to the next part, what we're going to want to do is, now that we have basic lighting understood, we're just going to add in some temporary lighting. Let's go ahead and switch back to unlit mode. Let's drop a few more lights into our scene, like this, and we'll just put these, wherever. It's all up to what you feel like. This is the aesthetic part. This is an example I'm running through. And it's just to give us a basic feel of what we want things to look like. Now if I want to adjust some things, maybe pull these out a little bit. Maybe give it something like that of an effect. Oops, that would be the wrong direction. That's the direction I meant to go. Something like that. We'll give it a little bit of an effect. Like that. We still have our circles. See, if you pull these out far enough, you'll no longer see your radius, which might be useful for the effect you're going for. We'll just give ourselves a nice, look at that, nice bright room. You can of course adjust things, like for example, maybe I want to take these lights. Oh, apparently do I have more than one light over here? What's that? I think I have more than one light over here, don't I? Oh, why is it? That's weird. It's showing 2 light bulbs. Oh wait, why is it showing 2 light bulbs? Well, that's a weird bug. It's showing 2 light bulbs. Okay, we'll go ahead and go back to selecting all 4 of these like I meant to do. And we'll maybe adjust our color to something a little more yellow. Go with something like that, a little bit yellow. Then we can always go in and we can adjust the intensity down on all of these. Maybe something like 3000. Give it a little bit softer effect. Our radius itself might be a little bit big. Let's go 600. And we'll go something like that. And see, we have a nice little soft effect in our corners. Now we don't actually have any lighting on our floor properly. You notice we had the issue with static lighting. Dynamic doesn't use the UV maps in order to do lighting. So that's one difference. Because there was no material and no UV mapping on our floors and our ceiling, we had the black. Because we switched to dynamic lighting, it's creating everything in real time, and so it's going to use our default material, and we're actually going to have something. Now that's not necessarily what we want, but this is what we have. what we're going to want to do now is assign some materials so we can see how the lights interact with our materials, and so we can have something other than just our plain grid material and things like that. So in our, why does that still say, yeah, see, this says none because there's still no material assigned, so it still shows preview. So that's one of those bugs we're going to fix here shortly. So we learned the different lighting types. We learned the basics of lighting. It is aesthetic. If you want to make some changes, I would highly recommend doing it now. Move some things around, play with your different settings, adjust your, maybe, let's see, our attenuation radius might be a bit, well, actually, you could do something like that. Heck, you know what? We could do something like this. We could do this. And then we could take this one light and we'll move it into the middle of the room. And we'll turn our attenuation radius up. And we'll do something like that. And there we go. We have one light now lighting our entire room. You may not, see a light source or anything like that. But the point is when we're playing, we might get a nice feel. Whoops. Of course, I'm going to fix that in a second. I'll fix that between videos. But basically, you're getting a nice look of this room with a nice single light. So, it's going to wrap up our lighting video. We are going to move on to materials. I will fix by adding collision to my floor. Actually, you know what? I'll fix it right now. Again, open it up. Go to your collision. Add a box simplified collision. Save it out. And then we now have our floor where we can walk through. Of course, we need to fix our stairs. Now, this is actually an interesting one. Okay, actually, you know what? This is an interesting one. We need to fix the collision on this. So what would we do? If we had a box simplified, we're going to have a problem. We have no collision as we go down. If we remove that and we add something simpler, like let's go with a 10 DOP, we have, as you can see, a little bit of a slight, not quite what we want. Maybe we want to do something like 26. No, still not quite what we want. What we're going to want to do is auto convex collision. And what I did there was, let's get rid of it. Well, let's go to collision and remove collision. What I did was collision, auto convex, and auto convex is basically going to try its best to build around. Down here we have our convex settings. We hit apply. It's going to calculate, and as you can see, it gives us a nice ramp down. We'll save this and run it. And you'll notice we have a nice smooth ramp down. You can't really tell that we're not really working on the stairs. This is one of those things that you have to play with later. And of course, apparently I deleted the collision from the floor again, didn't I? Collision, add box, simplify. There we go. Let's save that out. Save that out. Ay, caramba. These are all those fun things you run into when you're playing. Now we should not. There we go. Now we've got a stairs and a floor. In theory, a ceiling that I don't have collision on, so we might want to add that. I'm going to leave adding the collision to the ceiling to you, but we've got collision working for everything else. We will now move on to the materials video.